I gave sort of the overview of what I think SatNOGs is about, but why don't you give us, I guess, quite literally the 30,000-foot view?
Well, more than 30,000, but yeah, still. So SatNOGs is a satellite network open ground station. And what we're building is a network of ground stations, which is the setup that lets you talk back and forth to satellites, and specifically low Earth orbit satellites. And we focus on that because the majority of satellites are actually low Earth orbit ones, in contrast with what many people think about satellites, which is geostationary, the ones that we use mainly for TV and media streaming and everything else. So we're not talking about geostationary ones, we're talking about the low Earth orbit ones. And SatNOGs is creating a full stack of technologies, including the ground station, the antenna design, the receiving and transmitting, radio components, the embedded PC that runs on the ground station side, and then the network on top of that that coordinates all the different ground stations in order to provide scheduling and observational opportunities for multiple operators around the world.
Well, now, first off, you brought up a good point. These are not geostationary. So that means if I were to sort of be able to see this with magical eyes, it would actually be going across the sky. How long does it take to transit the sky?
Depends on the pass and depends on the satellite, but it would be a couple of minutes, up to 15 or 20 minutes. Still depends on the satellite, but definitely something which is moving, and that's why we need the rotator to actually follow the satellite across the sky. And once it's lost, we hope that we have enough ground stations around the world to actually follow the satellite after there is the loss of visual contact, basically.
Oh, okay. So you're talking about actually doing relaying so that as it goes from one ground station to another, you'd be able to maintain a continuous conversation?
Yeah, and we aspire to create a global network that can facilitate that 24/7 for all LEO satellites.
Okay, now these satellites are obviously there before you started this project. So how are people talking to them before?
So, first off, there was not necessarily a need to actually continuously talking to the satellite. But even when you have a satellite like this, before SatNOGs, you would have a rotator which you could get commercially from various companies that are actually building rotators, set up your own ground station, and wait for the satellite to pass above you to actually get such a contact. What SatNOGs is bringing on top of actually reconstructing the rotator using open source software and hardware, it's also the connectivity between the ground stations, so the network piece of it.
And how long ago did SatNOGs get started, and what triggered that?
So that's approximately a year now, and it was back in, well, more than a year. It was back in end of April last year, 2014. And we, as Hackerspace.gr, a hackerspace based out of Athens, Greece, we entered the NASA Space Apps Challenge, which is a yearly challenge, two-day event with challenges, space challenges that hackerspaces around the world are clustering around various projects and trying to provide solutions. And there was a specific project about developing a ground station, not necessarily a networked one. And we entered the NASA Space Apps Challenges. And during the weekend, we actually deployed the first version of a rotator. And after that, we actually wanted that to go bigger. And we thought, well, why, if you have a ground station, you don't actually connect multiple ground stations and create a global network? And that's how the SatNOGs project actually was born.
That's awesome. Okay, so now you're able, or you will eventually be able to have conversations with these LEOs. What do you say to them? What can be accomplished by talking to these things?
So initially, we're focusing on receiving signals from LEO satellites, and most of those signals are beacons, like status beacons, basically, of the satellites, and also the scientific payloads, the data from the scientific payloads that those satellites have. Most of the LEO satellites lately are scientific projects or commercial projects in CubeSats, and a CubeSat is a 10 by 10 by 10 centimeter, 1 kilo small satellite. And lately, we've been having hundreds of them out there every year. And most of them are experiments, scientific experiments, or it could be, magnetospheric measurements. It could be Earth monitoring systems. It could be experiments about radio communications or payload capabilities. So all of those have to transmit their scientific data back, basically, the results of the experiment. And we are focusing on receiving those kinds of payloads.
So is this government funded, university funded, or private and amateur stuff setting these up?
So are you talking about SatNOGs in specific, or are you talking about
I'm talking about the LEO satellites. How are they getting up there?
So pretty much all of the categories you mentioned. So there are many lately commercial projects from for-profit companies. Traditionally, there have been many governmental agencies that have been sending satellites on LEO. There's also many academic projects that are going up there. So a combination of pretty much all of them.